Hi, this is going to be a quick 10.13 update on a new feature called Configure Cable Length for Buffer Adjustment. My name is Steve Baker, Technical Marketing Engineer. Let's just jump right into it. Simple agenda. So, of course, what is buffering? Of course, this is, as we all know, this is physical memory, which is used to hold data while it's being moved from one place to another. And there's two main reasons that we use buffers in our networking devices. Of course, to capture intermittent bursts, and of course, to avoid packet drops when an interface is congested. And of course, buffers are found everywhere: printers, sound cards, NICs, switches. They can be on chip or off chip. And there's always a queuing structure involved, where this is the data structure which allows data to enter and exit the device in a different order. And that ordering can change on the fly depending on various conditions. And really, the bottom line is without effective buffering and queuing, frames are going to be more likely to be dropped during times of congestion. So what is this new feature that we're introducing? This is called Configure Cable Length for Buffer Adjustments. This is a command which helps us calculate the required buffer to help sustain the delay caused by a long cable. And it's leveraged in meters. You can see the range is from 1 meter to 100 kilometers. There's no reboot required. And it is only supported on 10 gig and higher interfaces currently with the 8325, the 9300, and the 10K. And we can see an example of this command when we jump into an interface on one of these switches. We can run the flow control buffer cable length command. And of course, that gives us the option of 1 meter to 100 kilometers. Or we could leverage the auto feature, which automatically detects the cable length when possible. Now, we already had another feature that was called the flow control buffer headroom feature. So now we've got two knobs that we can use to adjust the buffering on a device. So the legacy command was the headroom command that we could see here on the top example, where it's interface 1132, and we do the flow control buffer priority 3 and then give it a headroom in kilobytes. It's important to note, if both of these buffering configurations have been specified on the same interface, the headroom buffer limit is going to take precedence over the cable length option. And if no headroom limit or cable length configuration has been specified, or maybe the cable length is set to auto, but the hardware is not reporting a cable length, then a default cable length of 350 meters is just automatically used to compute the headroom limit. And I wanted to also leave you with the display buffer statistics command. So this specifies the usage limit for that specific interface. And for priorities that are configured for lossless behaviors, there's going to be two rows shown. First, representing the lossless pool, and then, of course, the second representing the headroom pool usage. We can see a simple example over here on the right, where we go into 112, run the QoS buffer command, or show QoS buffer command, and we can see that the cable length has been user configured to 400 meters. In the one below it, of course, we're running that exact same command, but this is an example where the cable length was hardware detected, and so the user didn't have to configure that 400 meters. They just used the auto feature. So like I said, this was a quick update. I hope that was helpful, and have a great day.